In today's lesson, we are going to find the solution for this ordinary differential equation. So the first thing first, you can see that there is this function which is being carried by dx. We also have this function carried by dy. This can show that this is n of y and m of x. So the first thing we can do is to try and separate the terms. Let's try to find a way where we'll have a function of y just being a function of y minus not having a function of x being accompanied by dy. The same for dx. So after, by observing, you can see that there is y with dx and there is x with dy. What can we do? We can just divide. Throughout by 1 over tan y multiplied by tan x. When we divide this by tan y multiplied by tan x, tan y and tan y will cancel. Here tan x and tan x will cancel. We are going to remain with tan y. Here we are going to remain with tan x. So let's go ahead and divide. We're going to divide by tan y multiplied by tan x. We're going to do the same thing here. We're going to divide by tan y multiplied by tan x dy equal to 0. So we can clearly see that this and that will cancel. Now we only have a function of y accompanied with dy and a function, and here it will be tan y and tan y will go, a function of x accompanied by dx. So the equation which we have turns out to be like this: tan x plus, this is dx, sec² y over tan y dy equal to 0. Now in this form, we can see that it has already been separated. Because we can just take this the other side. Dy will be alone, dx will be alone. So what we can just do is we can integrate. Let's just integrate all the sides. Now a question will come: how can you integrate this? The first thing first, we can try to ask ourselves, can we use u sub here? We can try, because you have to make sure that if your denominator you can turn into your numerator, then you can know that you can use u sub, because it will cancel. So let's say that I make tan to be my u and ask myself that when I differentiate tan, what do I get? My du will be what? The first derivative of tan, it is sec² dx. So I can see that if I make dx the subject, this will come at the bottom, it will cancel with that. So I can use u sub. So here, instead of assigning this to be u, tan y to be u, I'll assign it to be m. So my dm is the same as sec² y dy. So I'm going to make dx the subject and dy the subject. So dx is the same as du over sec²x. Then the dy is the same as dm over sec²y. So what I'm going to do is, where there is dy, I'm going to replace with this. Where there is dx, I'm going to replace with this. Then tan x will be equal to u, tan y will be equal to m. And we'll see how things will play out. So I have sec²x, tan x is the same as u, dx is the same as du over sec²x. This is plus sec² over, this is m. Now what is dy? Dy is dm over sec² dy. This is all equal to the integral of 0, which is the integral of a constant, an integral of 0. Now, when we can see that this and that will cancel. It's the same thing, sec²y and sec²y will go as well. Now, our equation is now looking like this. This is now what we have as our equation, dm over m equal to the integral of 0. We all know that the integral of 0 is a constant. We're going to get c. The integral of 0 is a constant. The integral of 1, it is going to be a letter. We are integrating that with respect to. But since it's 0, it's going to give you a constant, which is just c. So ask yourself in this form, 1 over u, when you integrate 1 over u, you're going to get the natural log of u. Then plus the natural log of here is going to be the natural log of m equal to what? A constant. This is all equal to a constant. Now, what was u? U was what? Tan x. What was m? M was tan y. So we're just going to replace them back. We're just going to replace them back. We're just going to replace them back. So what we have here, ladies and gentlemen, is the solution to the ordinary differential equation on top. What we have here is the solution for the ordinary differential equation on top. And we can try to prove and see if it is really is or it's not. How can we prove? We can just partially differentiate this. We can just partially differentiate the whole thing. So we can partially differentiate the whole fraction with respect to x. When we partially differentiate the whole fraction with respect to x, what we are going to find, ladies and gentlemen, is when we differentiate this with respect to x, the derivative of natural log of tan x, first you will need to differentiate whatever you have inside. The derivative of tan is sec²x over the same function you have, which is tan x. This is with respect to what? To x. With respect to x, this side is going to be 0 since it is carrying a function of y, and y, when you are differentiating with respect to x, partially with respect to x, is going to be 0 because you are treating it as a what? As a constant. When you partially differentiate this whole equation with respect to y, here this is going to be 0. Here you are going to get the derivative of tan y. It is sec² over tan y. Tan y dy, and this is the derivative of a constant, 0. Now we can try to compare. You can see that this is what you have there and this is what you have there. So this whole thing is still the same as that. Thank you for watching, and please, if you haven't yet subscribed to the channel, hit that bell icon so that you don't miss out on future endeavors. Bye bye.